Click the link in the description to download your own copy of this video's problem. Hey guys, Ross here, coming with a fantastic chemistry video, and today we're going to assign RNS to this molecule. Whoa, what is this thing? This thing looks really ugly. It's not that bad, actually. I'm just being harsh. It's pretty simple to do, actually. So this is a chiral molecule. We have a different group here, here, and here. Four different groups around a central atom, definitely chiral. Ooh, but does it ever look naughty? All right, well, we have to consider certain things. We have multiple bonds. We got to start considering those. So let's redraw this thing out, and then we'll do what Cahn, Ingold, and Prelog say to do. So we have carbon here in the center, a methyl group coming towards us, this group here, I'm going to draw it out as expanded because you never know what you can see when you draw things as expanded. Sometimes the forest through the trees will become very obvious very quickly when you draw things out. Sometimes it doesn't. But I think this one's going to help us out, actually. Not the neatest drawing I've ever done, but we don't really need it to be neat. We just need to see what's going on. All right. Well, I think priority group 1 is fairly simple to figure out. Or sorry, priority group 4, pardon me. We have if we jump out from the chiral center 1, 2, 3, 4, we're carbon all the way around. If we jump out from here, it's just hydrogens. So we know this is priority group 4. We know that's the low priority group. So we can just kind of ignore methyl from now on. We don't have to even worry about it. The question I have is it which one's 1? 1 is difficult in this situation. Is it this one, or this one? It's a very difficult choice. Let's go. Well, we're here, right? We jumped out to here. We jumped out to there. We're going to jump out one more. So from here, we can jump out to carbon. You know what? We can't do it that easily. I was thinking it might be simple, but it's really not. We have to draw these out. I'm going to draw them out because I don't want to be wrong. Let's call this A, and let's call this B. Because I have to draw them out like Cahn, Ingold, and Prelog say to do, right? So it's R, carbon, double bond it to carbon, to hydrogen, to hydrogen, to hydrogen. Cahn, Ingold, and Prelog say you should look at it as if it were this, right? Now, if you don't understand what I'm doing, there is a video I've made that explains all of this. Please go and watch it to learn how to do these break aparts, or the tool that Cahn, Ingold, and Prelog say to use. R, carbon, 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 CH3, carbon, hydrogen, hydrogen, carbon. Okay, so this is the breakout for, oops, I meant to draw that. Let me fix this real quick so it's more clear. Okay, so R is this, carbon, double bond it to carbon, hydrogen, hydrogen, CH3, and that's going to be this. Okay, now, we've already determined this is 4, so we're going to ignore it. So now we have to figure out from here, between these three groups, which one is 1. If I'm sitting here, I can jump out to hydrogen, to carbon. So for this group, it's going to be hydrogen, hydrogen, and carbon from here. Hydrogen, hydrogen, carbon. Okay? Now for this one, group B, we have to work here. So we're here right now. From here, we can jump out carbon, carbon, carbon. So this is 3 carbons all the way around. This is looking good for being priority group 1. But don't just jump to conclusions. Now here, we have to examine here. We're sitting on this carbon. 1, 2, 3. So carbon, carbon, hydrogen. We found it, ladies and gentlemen. We found it. Carbon, carbon, hydrogen. Carbon, carbon, hydrogen. So this, because we can jump out to carbon 3 different ways, this one we can only do it once, and then we're on a hydrogen. There's our difference. We know that group B must be priority group 1. And we know that group A is priority group number 2. And this is 3. Now, we also have to be very mindful of a question like this, because look at this. The low priority group is facing us, and it's not hydrogen. The low priority group does not have to be hydrogen. It often is, but it's not always hydrogen. It could be anything. So you got to be very mindful of that. So now our low priority group is in front. So how do we handle that? Well, we could turn it, we could rotate it, but unfortunately I'm out of space here in my sheet. So I'm going to show you a shortcut method that you must be very, very careful of. So the low priority group is facing the exact opposite of the direction it should be facing. It's facing the exact opposite direction. So whatever we get in terms of R or S, it must be the opposite, because this is opposite, right? This is supposed to be in the back, and now it's in the front. So if we determine R or S for this molecule, whatever we get, it must be the opposite, right? Make sense? Because this is facing the exact wrong direction. Whatever we get in terms of R versus S must be the opposite of what we see. Okay? So let's draw our line from 1 to 2, from 2 to 3, from 3 back to 1, from 1 to 2, from 2 to 3 back to 1. It appears to be R because it's going in the right-hand direction. But remember, this bad boy, priority group number 4, is facing the wrong way. So even though it looks like it's R, it must be S, because this group is facing the wrong direction. Don't believe me? Write that on a piece of paper, put a hammer and nail through here, hold that the ethylene group here in place, and rotate the bottom. And you'll see that this, although it appears to be R, is actually going to be S. Now, yes, ladies and gentlemen, this is a challenging one. Don't let that faze you. Go ahead and work on it yourself. Draw it on paper. Try yourself. Good morning.
Good morning. How are you?
Good, good. Thank you.
Okay.
5, 4, 3, 2. Now, this is a hard one, ladies and gentlemen. I'm not going to try to kid you and candy coat this. This is a very challenging one. It applied a lot of rules. So you have to know these rules to be able to apply it. Now, I want you all to try this again on your own without watching me do it. Make sure you can do it. If you can do it on your own, you're probably really, really set up well to do stereochemistry on an exam. If you can't do this, keep trying until you can, or come to office hours, figure it out. All right? We got to get this done. It's not as hard as you think. Now, if you have no trouble doing this, 5, 4, 3, 2. Now, don't get discouraged if you couldn't do this one right away. It was a little bit challenging. It applied a lot of different rules. That's okay. Turn the video off for a second. Work it out, write the question down, work it out on paper, rewind the video to the beginning, and watch again. Okay? Make sure you got it right. If you got it right, you're probably set up really well to do stereochemistry. If you got it wrong, maybe do some more reviewing and maybe go to your faculty member for office hours, get help with it. It's really not as bad as you think. Now, with that, ladies and gentlemen, I want to ask you to please slap that like button. Go ahead and subscribe to my YouTube channel. It really does help me out when people subscribe. Keeps me motivated to keep making more videos for you all. Also, share my content with your friends and family who may be taking organic chemistry or will be taking it in the near future. Hopefully, I can help them out to pass this, because we're kind of all in this together. We all want you to pass. And if you could, please leave a comment down below. Let me know how you're doing with organic chemistry. And with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.